Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving quadratic equations using the square root property. Before we get into how to solve quadratic equations with the square root property, let's review how to simplify square roots. So in example 1, it says write each expression below in simplest radical form. So in problem A, we have 3 times the square root of 64. Now, hopefully you remember that the square root of 64 is 8. So this is simply 3 times 8, which would give us 24. In part B, we have the square root of 4/25. Now, notice in this problem, the numerator is a perfect square and the denominator is a perfect square. So what we can do is we can just take the square root of 4, which is 2, and the square root of 25, which is 5. So square root of 4/25 would simply be 2/5. All right, problem C, we have square root of 18. Now 18 is not a perfect square, but I can break it down to the product of a square root, perfect square, 9 times square root 2. Now the square root of 9 is 3, and the square root of 2 will not break down any further. So square root of 18 is the same thing, or is equivalent to 3 square root 2. All right, problem D. Hopefully you've learned how to simplify the square root of a negative radicand. And you'll remember that when we have the square root with a negative radicand, we can use the imaginary unit I, because the square root of -1 is equal to I. So if I were breaking down square root of -32, I would start by pulling out square root -1, and then I would rewrite 32 as the product of two perfect squares. So this would be square root -1 times square root 16 times square root 2. So the square root of -1 is I, the square root of 16 is 4, and square root 2 will not break down. Now I want to rewrite I times 4 as 4I, so we'll have 4I square root 2 as my final answer. All right, 2 times the square root of -75. So this will be 2 times the square root of -1 times the square root of 25 times the square root of 3, which would be 2 times I times 5 times square root 3. Now simplify that by multiplying the 2 and the 5 together. So 2 times 5 gives us 10I square root 3. All right, pause the video and try problem F on your own. All right, welcome back. Hopefully you simplified this as 4 times square root -1 times square root 16 times square root 3, which would be 4 times I times 4 times square root 3, or 16I square root 3. All right, now let's look at the square root property. For quadratic equations of the form x squared equals a, the solutions will be given by x equals plus or minus a. So the square root property only works on problems that can be written in the form x squared equals 16 or x squared equals 24. There can be no bx term when you're solving problems with the square root property. So the square root property is a very useful way to solve problems that look like this, but it wouldn't really work on problems that look like this, x squared minus 6x plus 8 equals 0, because you've got that b term. You're going to have to use something like completing the square or quadratic formula. So again, it only works if there's no bx term. All right, so it's limited in its usefulness, but when you can use it, it makes your work much quicker. All right, in example 2, it says solve each equation and write your answer in simplified radical form. So in part A, we have 4 plus 3x squared is equal to -77. So we'll start off by getting this 3x squared term by itself. So I want to subtract 4 from both sides, and that would give me 3x squared equals negative 81. Then divide both sides by 3, and that gives me x squared equals negative 27. And then we're going to take the square root of both sides. So x squared would equal plus or minus square root negative 27. But the question told us to write our answer in simplified radical form. And so we need to simplify the square root of negative 27, which that would be square root negative 1 times square root 9 times square root 3, which would be 3i square root 3. So x would equal plus or minus 3i square root 3. All right. So in problem B, we have r squared minus 4 divided by 3 is equal to 7. So when we have a problem that has a fraction on one side, we need to begin by clearing our fractions. So I'm going to multiply both sides by the denominator, which in this case is 3. All right. So over here, the 3's cancel and leave me r squared minus 4. On the other side, we have 7 times 3, which is 21. Add 4 to both sides, so r squared equals 25. And then take the square root of both sides. So r equals plus or minus 5. R equals plus or minus 5. All right, part C. Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. I subtracted 5 first, so 81m squared equals 16. Then I divided both sides by 81, and I got m squared equals 16 over 81. Then I took the square root of both sides, so m equals plus or minus, the square root of 16 is 4, the square root of 81 is 9. So m equals plus or minus 4/9. All right, example 3. A rock falls from the top of a cliff to the ocean 100 feet below. The distance s the rock is from the ocean as it falls is represented by the function s of t equals negative 16t squared plus 100, where t represents the number of seconds the rock has been falling. According to this function, how many seconds does it take for the rock to hit the water? So we want the height of this rock to be 0, because that will be its height when it hits the water. So I'm going to plug in a 0 for s of t equals negative 16t squared plus 100. Now, if it makes you feel better, rewrite this equation with the variables on the left and then solve. So we'll solve by subtracting 100 from both sides. So negative 16t squared equals negative 100. And then we'll divide. T squared equals negative 100 over 16. And then we'll take the square root. So t is equal to plus or minus the square root of 100 is 10. The square root of 16 is 4. Now, the question asks how many seconds will it take? We can't have negative seconds, so I'm going to disregard the negative answer in this problem. And positive 10 over 4, when we're using time, we don't usually describe time with improper fractions. So 10 over 4 is the same thing as 5 over 2, which is the same thing as 2.5 seconds. So it will take 2.5 seconds for the rock to hit the ground. All right, example 4. Solve each of the following. Write your answer in simplified radical form if necessary. So in problem A, we have r minus 2 squared minus 5 is equal to negative 23. So I'm going to start out by adding 5 to both sides, and that would give me r minus 2 squared equals negative 18. Then we'll take the square root of both sides. So r minus 2 would equal plus or minus square root negative 18. Now let's simplify square root negative 18. That would be square root negative 1 times square root 9 times square root 2, which would be 3i square root 2. So r minus 2 equals plus or minus 3i square root 2. And then add 2 to both sides. So r would equal positive 2 plus or minus 3i square root 2. All right, problem B. 2x minus 3 quantity squared minus 10 is equal to 15. So I'll start by adding 10 to both sides. And this would leave me 2x minus 3 quantity squared equals 25. Now I'll square root both sides, and that would give me 2x minus 3 equals plus or minus 5. All right, add 3 to both sides, so 2x equals 3 plus or minus 5, and then divide by 2. So 3 plus or minus 5 divided by 2. All right, now let's get our two answers here. We have 3 plus 5, which is 8, and 8 divided by 2 would give me 4. And then we have 3 minus 5 would be negative 2, and negative 2 divided by 2 would be negative 1. All right, example 5. If f of x equals x minus 2 squared minus 9, answer the following. Part A, what is the vertex of the function? Well, remember from previous lessons, the vertex of the function is our h. Okay, so our vertex is 2, comma, negative 9. Part B, use the square root property to find the zeros of the function. So if I want to find the zeros, that means I need to plug in a 0 for f of x equals x minus 2 quantity squared minus 9. Again, if it makes you feel better, you can rewrite this expression as x minus 2 quantity squared minus 9 equals 0. And then we're going to solve for x using our square root property. So add 9 to both sides to get x minus 2 quantity squared equals positive 9. Square root both sides, and we get x minus 2 equals plus or minus 3. Now add 2 to both sides. So x equals positive 2 plus or minus 3. So now we're going to get our two solutions. 2 plus 3 gives me 5, and 2 minus 3 gives me negative 1. So in part Z, it says use the vertex and zeros to sketch the function. So our vertex was 2, negative 9, and the zeros of the function were at x equals 5 and x equals negative 1. So I will put my vertex on first. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I will label that with a V. Okay. My positive 0 is at 5. 1, 2, 3, 4, 5. Put a little z there for my first 0. And then we have a 0 at negative 1. So that's our other 0. So now we know that this is going to be a parabola that opens up. And we're just going to make a little rough sketch here. So make a U-shaped graph, something like that. And that concludes today's lessons, solving quadratic equations using the square root property.